Hi folks, today I'm here to talk to you about your app's front door. And these are common architectural patterns I've seen over implementations of authentication solutions, including Fusion Auth, for hundreds of applications. So the first thing to acknowledge is that your users really care about getting in the front door. They care about the awesome features you've written. They don't care about authentication. So these patterns are all things that help you build more robust, more secure, more flexible authentication solutions. At the end of the day, your users want to get in the front door. I'm going to talk about different patterns. I'm going to name them. I'm going to also discuss how they help and the trade-offs in using any of these. The first pattern is called Identity as a Service. I'm also going to talk about slow migration. Federation is a big thing in the identity world. We'll talk about the identity facade, the Auth gateway pattern. We're going to talk about logical multi-tenancy. There are multiple kinds of multi-tenancy, but we're going to discuss logical multi-tenancy. We're going to talk about organizations as a different way to separate your users out. We'll discuss bearer tokens, the BFF pattern, the username first pattern, and then finally impersonation, where we allow one user to impersonate another user. Real quick about Fusion Auth, we are a customer identity access management solution, and we take undifferentiated heavy lifting around authentication and authorization off of your plate as a developer and let you continue to focus on building features that your users want. So these would be things like login, registration, forgot password, IDP management, profile management, MFA enablement, security features around MFA and login, and more. Let's talk about why you might be interested in using patterns. So Christopher Alexander, in his book, A Pattern Language, laid out various architectural patterns, but this is not software architectural patterns, this is actually real built structures. So that would include things like long hallways and windows and forums. And developers do the same thing. We name something that we see over and over again, and that lets us work at a higher level of abstraction. So I, for one, cut my teeth on Design Patterns, which is a book. It's also called The Gang of Four, and it's a book that lays out a number of architectural patterns, and this was in the 2000s, so people have been thinking about patterns for decades. One reason to use a pattern is for a common nomenclature. If developers agree on a name for something, let's say the observer pattern, where we have two components that are loosely coupled that can send messages and receive messages, then developers across the world can use that to mean the same thing. And that makes documentation easier, makes understanding systems easier. Another great reason to use patterns is they arise from common problems. So back to the observer pattern that I mentioned before, it's very common for you to need a way for two subsystems or architectural components or even objects or pieces of software to be able to talk to each other without knowing that much about each other. And so this pattern, as implemented over and over again, specifies this very lightweight, low-touch way for these two components to interact. And you'll start to see patterns over and over again as you build more software, because very often, while the details of the software are very particular, the overarching architectures are very similar across different software packages, domains, and applications. Because I like to tell stories, I'm going to talk about cosmosclownstore.com, which is an e-commerce site. And we're going to look at all these authentication architecture patterns in the context of Cosmos, clownstore.com. So the first pattern is Identity as a Service. So this is basically one place to log in. So you delegate authentication, authorization, and user management to a central server. Rather than having it in your applications, you extract it from your applications, and then you have one place for your users to go. In some ways, you can think of this as normalizing your user data. And so the same way that you have trade-offs and benefits from normalizing data in a database table, you have one place to go to change data, you have one view of the data, you have one schema for the data, you get the same benefits from normalizing your user data. There's one place for users to go to update their profile data or their credentials, one view of the user. You can hang other things off of that user data and observe when it changes. The costs, of course, are that now you have to go to one place to make changes to data. This is also known as any of these terms, OIDC or OAuth server, where OIDC stands for OpenID Connect and OAuth stands for Open Authorization. Those are both standards. And some of you who may have been in the IT or software industry for decades will recognize the term directory. All these mean the same thing, which is basically one place to store user identity data. Here's some common implementations, and some of these range from the 90s to more recent implementations. The way this works from an architectural perspective, here is our set of applications before we introduce the identity service. We have two applications. They each have their own user data stores. So that means if I have a user who registers for Cosmos Cloud Store for the e-commerce application, they will have their own credentials and their own profile data in the user's data store. And then if that same user goes and registers for our forum to discuss red noses, rainbow wigs, and long floppy shoes, their user profile data will be stored in the other user's data store. If they want to change something about their preferences or their email address or whatnot, they have to do that in two locations. If we introduce a identity as a service server, then auth.cosmoscloudstore.com owns the user's data, and both Cosmos Cloud Store and the forum delegate to that server. That is the owner of the user's profile data now. And there are standards that specify how Cosmos Cloud Store and the forum can interact with this server. But from an architectural perspective, all we care about is that they now are forced to every time they need to get user data. Now, one thing that's worth noting is that it's a very trivial application that only has user data. Most applications have much more data. Users are a critical entity, but not the only entity. The e-commerce store and the forum will each have their own application data. And that application data will probably reference the user's data store. Because these are distributed databases, it's probably going to be a soft foreign key, right? It won't have that same referential integrity that if you store everything in one data store. The benefits of this are that you have one place for your user data. You can add on additional features that matter for users. This could be something as simple as multi-factor authentication and requiring that for e-commerce purchases or logins that access the e-commerce site. It could be something a little more sophisticated like email notifications if a username or a password or a multi-factor authentication method has been added or changed or removed, or it could be adding on a new standard, supporting something like passkeys or magic links. All of that can happen at the identity server, and the downstream applications don't actually need to be modified at all. As long as they still trust the response from the identity server, you can add on additional things to the authentication process without affecting the downstream applications. Another thing that is a benefit of this pattern is that you have a single point of control. You have one place for your users to be seen, be controlled, right? So if you want to prohibit access to the forum because somebody is not behaving, you can go one place and remove their access to the forum. Perhaps you're going to disable their ability to buy things from the e-commerce store. If you have other applications, you can modify a user's ability to access those as well. You can isolate your personally identifiable information. So all of your user data, if you choose to use the identity as a service as a profile store, you can put anything that is sensitive that needs to be managed in a way that's compliant with government regulations that can be in this one central data store. That has a couple of benefits. One, you have one place to go do audits or to get access to user data. The second is that you can really lock down access to that data. You can lock it down like at the network layer, right? Because if it's an isolated server, you can lock it down in terms of who has access to it or who can, what entities can get access to that. And then you can make sure to lock down how the software changes over time. Another benefit of this pattern is that application developers don't have to care about security as much. They still have to care about security of all their app data, but now this huge chunk of pretty important data around their users is off their plate, and they definitely don't have to worry about things like credential management. There's always trade-offs. You don't get all those benefits without some costs. And so one cost might be your identity server is going to control some of the authentication experience for Cosmos Cloud Store e-commerce site and Cosmos Cloud Store forum. And Cosmos Cloud Store example, they may have slightly different look and feels. And so you need to make sure that your Auth server matches the look and feel that you have for your different applications. This is especially true if you start to think about like a SaaS offering where you have different organizations or different companies that may be interacting with your SaaS application and what their users expect from an authentication experience. This also now introduces another architectural component into your system. Because it's your app's front door, you're going to need to have really great uptime, because the last thing you want to do is have someone get all excited about trying out your application, and especially if it's a consumer facing application, and then have them not be able to log in. That's a really frustrating experience. So make sure that you understand what kind of SLAs you need and what kind of uptime requirements you're going to have to meet with this identity server. You may, if you're in a large organization, have multiple levels of delegation. I've talked a lot about having all of your PII and your user profile data in a single identity server, but in a, it depends on the size of your organization. You may end up needing to delegate from one identity server to another. We'll talk about that a lot more in the Federation pattern that's coming up, but just to be aware that you may not be able to have all of your data in one repository. There may still be some delegation going on. There's also the question of authorization. We talked a lot about authentication, which is knowing who the user is, but we haven't talked a lot about authorization, not knowing what the user can do. Some of that could be rolled up in this identity server. FusionAuth, for example, has a pretty strong RBAC solution that's built into it, but authorization is often wrapped up in an application's business logic. And so it's possible that you may need to put authorization into your application. There may be built-in authorization in, say, the forum software you're using, or a third option would be to use a tool, something like OSO or Permit.io or Cerbos, which is an external authorization server that can let you build more complicated authorization logic. The second pattern, which is slow migration. So if you've ever done a data migration, you know that data migrations are complicated. There's always edge cases, there are always surprises, there's always things that you didn't think of, and it's really hard to do them right. When you are migrating users between identity servers or auth systems, whether that's migrating from your own homegrown auth system up to a identity provider like FusionAuth or Auth0, or from one identity provider to another identity provider, it is even more complicated than a normal data migration. You have all of the difficulties of a normal data migration, and then you also have the complexity of a password hash. So I'm going to walk you through password hashes briefly. This is definitely not a full masterclass on password hashes. Basically, password hashes are the way they are because we want to make sure that people can log in with something that they know, and hopefully they alone know, and we want to secure it in such a way that if somebody else gets access to our database, they don't suddenly get access to all of these users' passwords. So what we do is we take a string like clowns and we run math over it. And this math has a couple of attributes. One, you want it to be standardized and like a well-known algorithm that has been tested and determined to be secure by very smart mathematicians. Two, you want it to be deterministic because you want to always have the transformation. If you pass in the same initial value, you want the transformation to always be the same. You want it to be one way so that you can pass an input and get the output, but not go from the output to the input, because we're going to be storing this in a database that might get, unfortunately, stolen or hacked. And then you want it to be not too fast and not too slow. You want it to be not too fast because there's an attack against these kind of authentication systems. Attackers just try a dictionary attack, and attackers just try different words over and over and over again. And if you can make it take long enough, then you will cause that attack to be, it's not stopped, it's just more frustrating and slower and worth less. It's a less feasible attack if you make this algorithm not too fast. You want to make it not too slow because you don't want your end users, they're typically only entering in a string at the very beginning of their authentication session when they're trying to get in the front door. You want to make sure that their experience is relatively pain-free. So you don't want to take a second. You want it to be a perceivable amount of time, but you want it to be slow enough that it's going to stymie attackers. This math happens and we get back what is called a hash. And this hash, because of all those attributes of that math, is safe to store in our database. So we do this all at registration, right? When someone provides their password, first time we store this hash. The next time they come in, they will present that same string. We can run it through the same math. And if we get back the same hash, we know that they're someone who possessed that original secret. If it's a different hash, then we know that it's not that. And so we should deny access. So if you're talking about migrating passwords, you have a couple of options here. The first is you can import the hash. And so again, we're moving from one system to another. If you can do the hash import, that's the best option. What that's going to let you do is it's going to be transparent to your end users, because again, that math will be the same whether you're in system 1 or system 2. The issue with this is that not all providers support that. FusionAuth actually, I think, personally does a great job of that. We have a way for you to import standard hashes, and then we also have a way for you to kind of build your own hash provider if you're using something that is non-standard. But a lot of providers don't support that. If the provider does not support the hashing algorithm that you use, then you can't import the hash, and therefore you have two other options. The first is to reset everyone's password, right? You just import them with kind of a generic string, and then you say people need to reset their password before they can log in. That works great if you have an email address for everyone, or some other way for them to kind of automatically reset their password without calling customer service. It is a little bit of a user experience nightmare, because depending on how often your application is used, it's possible that people may have forgotten that they were even registered for it. People may have, no longer have access to the email address they signed up with. And frankly, people may be a little suspicious of an email saying, hey, go ahead and reset your password for, cosmoscloudstore.com. That is definitely a legitimate email, but it also is one that phishing attacks use. If you don't want to reset your users' passwords and you can't import the hashes, then the slow migration is the best option. This is also known as a drip migration, and here are some common implementations, identity providers that support it. Let's say that we're moving from a homegrown identity server to our new shiny identity as a service provider. Here we are beforehand, where a user's passing in the string clowns, and then we call that math, right, which turns into a hash, and then we store that in the users table. That happens at registration, and then at further logins, as I mentioned before, the user passes in string clowns with a 0, and then we rehash it and compare it to the value in the database. We introduce the new identity server, which is living at auth.cosmoscloudstore.com, and basically the user's going to provide their password to the new service, which is going to immediately pass it on to the old service. And they're going to do that over plain text, which basically means you need to make sure that it's locked down, right? That this endpoint isn't open to anybody. You can lock it down via custom headers, via allow lists, via network connectivity. Make sure you do it over SSL. Then the homegrown identity server needs to be able to take the value of the user information and the password and determine whether that user has correctly logged in or not. And the way it's going to do that is it's going to rehash, or it's going to hash that string. It's going to compare the hash that it generates with what's in the user's data store. Then the homegrown identity server is going to pass back a thumbs up or thumbs down. If it passes back a thumbs up, the auth.cosmoscloudstore.com can now rehash that plaintext string because it keeps the string clowns in its memory. So it can rehash that in whatever new hash algorithm it wants to use. And then it can store that off in its own user's data store. The next time the user comes in, right? So that was the first time the user logs in when we're starting a slow migration. The next time they come in, they present the string clowns, and the new auth system has marked that user as having been migrated, and so it can check its own data store. It never has to check with the homegrown identity server for that user again. And eventually, you can actually get rid of that old system. So determining when to get rid of that old system is a slightly more complicated thing. You need to look at how many users you've migrated over and determine if that meets your needs. You need to think about what you're going to do with all those users that were unmigrated. But at the end of the day, this is the pattern. You eventually, without ever getting access to the password hashes in the old system, or needing access to the password hashes or the password hashing algorithm in the old system, you can move over everybody who logs in regularly. So the big benefit is users don't have to reset their passwords, and rollback is possible. Another benefit is that you never, as I mentioned just a previous slide, you never have to have access to those hashes. And sometimes there are some providers that don't actually let you have access to those hashes. So what rollback means is you can basically just remove the new auth system from the authentication pathway. If you roll this out and then you discover, oh my gosh, there's something wrong with the new auth system, you can roll back pretty easily. There are some definite downsides to the slow migration. A big one is that you're going to be running both systems, and you're going to be running them for a period of time that depends on how often your users log in and how many you need to be moved over before you can turn off the old system. Along with that, you're going to have different users on different systems. So some users might be, unmigrated. And so if they need a password reset or you need to look at their profile data, you're going to have to go look at the old system. Some users will be on the new system who've been migrated over. And so if they need to do things like, update their profile or change their password, you're going to need to do that on the new system. So that's, one of the big downsides of this. Let's move on to the next pattern, which is federation. So this is basically having trust between different identity servers. So this is oftentimes done with standards like OIDC or SAML. You have a shared secret typically between the different identity servers, and that means that there's some out-of-band configuration that happens that isn't automatic and it's not like snap-in, right? You need to copy a certificate from one place to another, a public-private certificate from one place to another. And this is very similar to the identity server pattern, where we have our applications like our forum and our e-commerce store delegate to the identity server, but here we're having one identity server delegate to another identity server. So this is known as single sign-on or social sign-on. If you are in a business to consumer context or a B2C context, you might delegate user identity to Apple or Google or Microsoft or Facebook or, TikTok or Instagram or one of the other consumer-facing big applications. If you're in a B2B or business-to-business context, then you might use a standard like OpenID Connect, which we've seen before, or SAML, which is a security standard. It stands for Security Assertion Markup Language. It's from 2005. It's widely adopted, especially in the B2B space. And if you're in the B2B2E space, which is business to business to employee, basically this means you're a SaaS company that is selling to clients, and those clients have employees. Then you're going to have OIDC and SAML also, but you're going to have a lot of different configurations. And you're going to need to support delegation of the configuration of those OIDC or SAML connections to your clients. So the way this works is that rather than the auth.cosmoscloudstore.com owning the user identity, when someone tries to log in to cosmoscloudstore.com through our identity provider, our identity server, we're going to forward them to Google. Google is going to check to see that this user is logged in, and that's basically entirely out of our understanding or caring. We don't care how Google does that. We don't care if Google requires two-factor authentication. We don't care if Google recognizes them because they checked their Gmail this morning too and just forwards them immediately back to us. We don't care if Google recognizes their device is a new device and so forces some other level of authentication check. That's not really something we're concerned with. Google sends back a thumbs up or thumbs down, and then we can store some information. It's not just a thumbs up or thumbs down. They may send back other information about, the user's email address, the authentication time that it happened, or other information about the user. We can store off some of that, and then we can forward the response back to our client with a thumbs up or thumbs down. So a big benefit is that user identity becomes someone else's problem. It's on Google or on Facebook or on Microsoft or whoever, it's on them to authenticate the user. That's good for us because we don't have to worry about storing those credentials. Us being cosmoscloudstore.com, it's actually good for the end user too, because that means they have fewer credentials to worry about. If I had to pick between trusting Google with my identity versus trusting a random e-commerce website or forum, I'm going to lean towards Google most of the time because Google has teams of people thinking about securing my identity as opposed to an unknown number of people who think about it at cosmoscloudstore.com. It can be a better user experience. It's possible I logged into Gmail this morning, so if I click login with Google, I am immediately sent back to the application, which again, that's where I want to go. I really don't care about authentication. In some studies, they found that there's an 8 to 10% lift when you offer social sign-on to your users in terms of the number of people who convert over a given period of time. You also can ease registration, and that's because, again, the profile data, the identity stuff is someone else's problem. Whatever the user chooses to let Google share with us, that's something that Google maintains and we don't have to worry about it. So the user's not having to type in stuff to register. And I already mentioned the increased conversion that can happen. The trade-offs are that you have another architectural component that now your application depends on. You can do both, right? You can have local login and federated login. So it's not like an either or proposition, but it is one more thing that your users and your application now depend on. It can be somewhat difficult to integrate with some of these third-party providers. Some make it easy, some make it a little more difficult. It's another dependency. A big thing that you need to be aware of is that you are now dependent on this remote identity store for the authentication of your users. So you really have to trust them. Let's talk about that a little bit more. Suppose there is a bad actor out there who somehow manages to hijack an identity provider. So we're not going to talk about Google because it's extremely likely that someone will be able to hijack Google, but we'll talk about OpenID Connect. Suppose we have an administrative login and we have an OpenID Connect server out there that we let someone else configure. And so someone configures it well, but our Auth server depends on this external third-party OpenID Connect server. And so when someone logs in, we forward them off to this server. The server does the validation and then sends back a thumbs up and some other information. And then we pass this response back to the end application. The user has been authenticated to our requirements. But if there's a bad actor out there who somehow gets control of this identity server, they somehow are able to control the credentials of this admin at cosmoscloudstore.com email address, then when we log in, we are again passed on to the OpenID Connect server. We do this validation, but we actually have, those credentials are owned by somebody else, right? They're owned by the bad person, or the bad person knows them. And then we get that thumbs up and we pass that back to the application. And so because of their control of something that we implicitly trust, or explicitly trust to be more precise, they now have admin control of the application. Basically, the takeaway there is you need to be careful who you federate with. And this is especially true in the world of B2B2E, where you delegate some of that federation control to your possible clients. And you can mitigate this with additional checks. One example would be to actually have MFA enabled at the auth.cosmoscloudstore.com so that even if the user authenticated with the identity provider, they would still have to provide additional factor of authentication before the application was told, hey, this person's doing great. So let's walk through that. So the user's already been logged in via the bad OIDC server, and then we actually do a check here and say, hey, please, we've sent you an MFA code, please enter it in again. And that removes the possibility of the bad actor seizing control of the OIDC server and hijacking the account, because you have stored in the auth.cosmoscloudstore.com data store, you've stored the MFA method it is and how to verify that it's correct. So it's outside of the bad actor's control. Pattern 4, the identity facade. So the idea here is that we have a dev-friendly interface, and this is really useful for embedded applications. So we have one customer that actually has a application that gets sent to users' data centers. Rather than the data going to the application goes to the data. And it could be sensitive data, could be data that enterprises just don't want leaving their premises. This user of FusionAuth, they want for their customers, users of this application, to be able to log into their customers' identity servers, right? Their directories, Active Directory, Azure AD, Okta, whatever it is. But they also want their developers to not have to understand all of that. And so that's what this pattern is really good for. You have your application itself, the thing that's getting shipped around to different data centers, which is not a SaaS, right? It's like an embedded application. It only talks to the identity facade, and then the identity facade is what's responsible for talking to all of these other identity servers. So we've seen that with Keycloak, and we've seen that with FusionAuth. The way this might work is you have a cloud data application, which needs to talk to, when it's embedded in the Kmart data center, it needs to talk to the Kmart identity provider. If it's in the Atlanta Pacific data center, it needs to talk to the Atlanta and Pacific identity server, and same thing with Mervyn's. So in each of these cases, you have specific configurations, and the Kmart one could be Okta, the AMP one could be Azure AD, and the Mervyn's one could be Google Workspace, right? They could all be kind of disparate, and you either have the cloud data application able to talk to each of them, or you introduce a facade, and that facade is now responsible for talking to each of these identity providers. So the benefits of this are that you have the single API and understanding for devs, and then the bigger thing is probably the win of outsourced maintenance. So because the external facade is good at identity, then it's going to keep track of any changes that are made to those external identity providers, or the team behind it should. And that's both in terms of the actual functionality, but also in terms of the documentation. You can basically outsource the documentation for configuring an integration between an Okta and the identity facade to the identity facade provider. That documentation is something that can change over time. And you want to make sure that you're getting the full benefits of the identity facade by delegating that out, responsibility for the documentation, to the identity facade provider. So basically, as the developer of the cloud store data application, you can actually say, hey, you want to configure an Okta identity provider for our application? Go ahead and just log in and follow these instructions that are provided by the identity facade provider. Again, you're introducing another architectural component, which increases the complexity of your system. You have to have it be an embeddable solution. So this is not a pattern that's useful for SaaS applications, or frankly for SaaS identity providers. Next pattern is the Auth gateway pattern. So this is basically letting you offer single sign-on for applications that might not have been meant to be put on the internet. It could be an application, it could be a set of documents, it could be a file share, and you want to bring it up to the internet because we live in the age of SaaS and everyone wants to be able to access anything from the internet. Common implementations are HA Proxy has one, Kong has one, other gateways that are designed to kind of sit in front of a bunch of applications. I think F5 has one. And it's usually paired with an identity server that does the actual authentication stuff. The Kongs or HA proxies, they take care of the enforcement, but the actual authentication happens with an identity server. So this is how it used to be and still is for a lot of enterprises, where if you want to get access to private data, for instance, reports on the latest clownware trends, you log into a VPN, and then that VPN basically gives you network access to the internal network. Then you can go to the file share and look up clownware PDFs. If we want to put it online, then we need to introduce this gateway. And so we have a gateway, and we also have a paired identity server, which is auth.cosmoscloudstore.com. So when a request comes in the gateway checks to see if it is a valid request, and basically does that typically by looking at a header or a token. If it's not, sends the request or the requester to the identity server, which first that will authenticate the user, then it will issue a token if that authentication is successful. And then from there, that token can be stored and then presented to the gateway when you're making the request for the PDFs. And then the gateway will examine that and then realize, oh yes, this is a valid request. It does that in a variety of ways, but let's just wave our hands and say that it does that. And then from there, it can return the requested information. So the benefits of this is that it's very easy to bring applications that don't have authentication online. And so that could be files, as we saw, or it could be something else. You get the same benefits that you do with bringing any application into an identity server scenario, which is you have that centralized access control. And at the same time, you can expose this information out on the internet, but still protect it. The trade-offs are that depending on the application's complexity and what it's looking for, if it expects a username and password to be presented to it, if it has its own concept of session, then you may need to modify that application to accept requests from the gateway, or you could have the user log in twice, right? Once to get access to the, everything that the gateway protects with that first identity server interaction, and then the second time with the actual application. But that's really, going to be a super application by application specific decision tree. And, some of these internal applications may have just one user, right? They may not have a sophisticated user store, and maybe there's just one username and password that you can put on the web page or the application's login page, because that it's been protected by the gateway. And then you can route all your traffic through the gateway and have all your users authenticate through the identity store. So let's talk about logical multi-tenancy. Before we dig into logical multi-tenancy, I want to acknowledge that there's a lot of different flavors of multi-tenancy. The idea behind multi-tenancy is that you have the same application code running in multiple different places, conceivably with different sets of users that this application is acting on, users and data. But we're going to focus on logical for this pattern. So where this really comes into play is that you're building a software as a service, or you have some other situation where you have the same application code, but you have different sets of users and different sets of data. With logical multi-tenancy, you run like a big honking server, have hundreds or thousands of different clients running against that server, depending on their needs and how big the server is, and then have them each have their own separate data and users. So how this might work in the scenario that we've been talking about, we have auth.cosmoscloudstore.com. We also have a couple of other e-commerce sites, rednoses.com and coloredwigs.com. They all point to the same identity server, but the identity server knows which user pool to send requests to, send profile change requests or authentication requests to, based on the hostname it comes in. So the CCS users, that pool will be checked when someone comes in from auth.cosmoscloudstore.com. Rednoses users, if they come in from idp.rednoses.com, etc. So one of the complexities around this is you need to somehow send the user someplace to a given user pool before you even know who they are. And so you can do this based on attributes of the request. The hostname and tenant mapping is the one I just showed you. You could, if you have different sets of users that are tied to different IP spaces, you could do IP mapping. You could, in some cases, have the user select which they should go to. The issue with that is now suddenly they're seeing a select box of all the clients that you might have. That may or may not be problematic depending on your user base. And then finally, if you have an external application that is basically tied to a particular user pool, then you could use that. An example of that might be if you have different mobile apps for each of those, right? Like Cosmos Clown Store has its own mobile app, and so does rednoses.com, and so does coloredwigs.com. If you have a different mobile app for each of them, each of those can have like a link into the correct tenant. There really aren't a lot of common implementations of this. A lot of times it's just kind of roll your own. If you do use a SaaS template like a Bullet Train, which is a Rails SaaS template, but there are others out there, they may have something like this that takes care of this mapping. If you use this pattern, you have clear separation of your users, right? Because they are each in their own separate user pool. The user configuration can be different. So you can have different sets of password rules, for example, or different sets of profile attributes for each user pool. It's very easy to differentiate look and feel, because the same way you know which user pool to send them to, you know what look and feel configuration to display. You can shard it pretty easily at scale. If you end up with a lot of users in Cosmos Cloud Store, you can break them out to a separate identity server because there's not very much shared between the different user pools. And then the other big win is that your users can have multiple profiles. And that's really, again, important in the SaaS world. If I'm a clownware shopper and I go to coloredwigs.com and I buy my colored wigs, and then I go to cosmosclownstore.com and I buy my jokes, well, I want to make sure, as the proprietors of either of those e-commerce stores, I want to make sure that a user doesn't think there's any connection between them, because the user shouldn't care about that. The user would be probably surprised or weirded out if they could use the same password to log into both of those e-commerce stores. Separation is actually a good thing. Trade-offs are, with logical multi-tenancy, there's a noisy neighbor problem. So if Cosmos Clown Store has a big sale, then that can actually degrade the performance of the rednoses.com or coloredwigs.com users. You end up with some data model complexities, and then because you're basically having one application with a bunch of different data tables, you pretty much have to kind of force everyone to either be on the same version of the API, or you need to version the APIs, and that has its own complexities. It's easy to version APIs when all you're doing is adding things. When you're changing the actual implementation or kind of semantics of an API, it gets a lot more complicated. And again, I mentioned that the fundamental problem with logical multi-tenancy is you need to know who the user is before you actually know who the user is, before they've even authenticated. And the last one is cross-tenant users are difficult. And this is a situation, again, back to the SaaS idea, you're probably going to have customer service reps that need to log into different e-commerce stores. And so if there's really true separation between the user pools, you're not going to be able to have a common user or a common set of users that work for your SaaS company and can go across different tenants. There are ways around it, but it's definitely a little more complicated depending on how logical multi-tenancy is implemented. All right, let's talk about organizations. This is a different way to structure separating your users. So previously with multi-tenancy, we had separate user pools where the users were absolutely subsidiary to the tenants, right? The tenants controlled the users or they own the users. With organizations, it's different. Organizations and users are peer level entities. So again, you can use the same code base, but you have one user pool. So you, instead of a user being controlled by tenant, basically users are associated with organizations and they can have different configuration or different requirements or different roles when they enter an organization, but they have to choose to enter that organization. And by enter, I mean like associate themselves or choose which organization that they're going to go into. In this scenario, the user comes first. So you authenticate the user, then you look up their organizations they're associated with, and then you can say, okay, this user is associated with N organizations. I'm going to show them the list they get to pick from, or they're associated with one organization, so I'm going to just forward them on, or they're associated with no organizations, and then I'm not going to let them go anywhere. There's only one login user experience for this because the login happens first. So you don't have that look and feel customization that you would get if you did multi-tenancy. So some common implementations, GitHub does this all the time. They do this very well, where you log in and then you see which teams you're part of. HubSpot has the same idea, and it is worth noting with this implementation is that you can model it in your application or you can model it in your identity server. So here's an example of HubSpot. I've created a couple of different accounts because I was messing around with the HubSpot API. I can choose, after I log in, I'm presented with a screen like which account do you want to enter into. We have our Cosmos Clown Store org, we have our Red Noses org, and then we have our Colored Wigs org. And you can see that the user at the top only has access to the Cosmos Clown Store org. The user at the bottom has access to all three organizations. So a benefit of using organizations are that users can join and leave them in a dynamic fashion, right, over time. Again, think back to GitHub teams. I've definitely joined a team and then left a team, right? When I join a company or a project and then leave a company or project. The organizations themselves can have unique roles and policies, but they may affect the user experience, but they can't own the user. You can shard organizations at scale depending on how you architect things, but there is that kind of nice delineation of which organizations someone's going to. The thing that owns that organization can actually be on a different server than the authentication server. The trade-offs are it's not standardized. As far as I know, there's no great drop-in implementations that are available and not a lot of tooling support. So you're going to be rolling your own basically. Even with Fusion Auth, we support this, but as a kind of a concept or as an entity, but we don't have a lot of tooling around it. So you're going to be building a lot of your own stuff on top of it. The next pattern is what I call bearer tokens. This basically is time-bound limited access. So it is an arbitrary string held by a client. If you hold that gets you access to some resource. And this is pretty well defined in RFC 6750, which is part of the OAuth 2 kind of core specifications. It depends on the actual implementation, but they're very often they're JSON Web Tokens, and that means that they have internal structure and that they're signed. A bearer token could be opaque as well, and Facebook's bearer tokens, for example, are. I always say that a bearer token is like a key to a car. If you hold the key and you have access to the car, you can get into the car and turn the key and then drive away, right? You have access to that resource of driving that car. The same way you want to take care of your key, you want to take care of your bearer tokens. Some common implementations are the OAuth Authorization Code Grant or the OpenID Connect flows. So let's walk through the Authorization Code Grant and how you get a bearer token. It's worth noting that there are three main components here. We have the Auth server, which is auth.cosmosclownstore.com. We have cosmosclownstore.com, which is a web application. And then we have the Clown API, which is the resource that we're protecting. That's going to give us back a list of clowns. The first thing we do is have a client that's interested in getting access to the Clown API. And it's going to present a bearer token to that Clown API. That's bearer token's role in this scenario. The client wants to get a bearer token. It's going to request an authentication form from the identity server, and then it's going to post credentials up to the identity server. The identity server is going to send back a code, a one-time code, and that looks a little bit something like this. And then that code is passed to the Cosmos Clown Store app, and that has a pre-configured secret. That secret and the code are passed to the identity server, to the OAuth 2 server, and access tokens and other tokens are returned. The bearer tokens are returned basically. And then we send those tokens down to the client. The client then presents that token to the Clown API, and the Clown API sends back that Clown information. So in this case, the jot, that gray jot is the bearer token. And here's an example of the data that you might get back. So the benefits of using a bearer token are that it times out. So every bearer token has a limited lifetime, which means that it's a lot less appealing to steal a bearer token. Even if you can get access to it, it's going to be time-bound access. Can you imagine if I was able to create a new car key and hand it to someone I wanted to have access to my car for 10 minutes, and after 10 minutes, the car key melted? That's what an access token does. or a bearer token does. They're portable, and so therefore they can be put in form parameters, they can be put in HTTP headers. Basically, they're very good for HTTP JSON APIs. If you use a token that is a bearer token that has internal structure, so it's a JOT or some other signed token, then you have the ability for the API to verify the validity of that token without talking to the identity server, which can lead to great scale benefits. It encapsulates identity in a stateless way, and it decouples identity from the identity server, right? So it's basically a cache of the identity server's answer for the period of time before it times out. As I mentioned before, bearer tokens are part of RFC 6750, so they're standardized. JOTs are part of HOSE suite of standards, so 7519 is the JOT standard, and a number of other ones. It's standardized across different organizations and different industries. The trade-offs are that you have to secure these well, right? The same way you'd secure a car key, you need to secure your bearer tokens. There are alternatives that exist that bind the bearer token more closely, typically through a cryptographic operation, to the access token. And then another trade-off is that they are short-lived. And you also can have a bearer token leak data depending on what it looks like, right? If it has internal structure and is, like, for instance, a JSON Web Token, depending on the type of JSON Web Token you're using, an attacker may be able to look at that JSON Web Token if they get access to it and see things like a user ID or other things like that may leak data about your internal system. The next pattern is the BFF pattern. This is not about best friends forever. This is actually the backend for frontend pattern. And the idea is that bearer tokens are great insofar as they go, but like even if you have them short-lived, they're still, if they give access to like very valuable resources like the ability to initiate a payment transfer, right, to be able to move money around or other things like that, it may be problematic for them to be stateless at all, right? It may be problematic for them to be a true bearer token, and you may not be able to use those alternatives I mentioned, which are still kind of nascent technologies. One way around it is to actually use a server-based backend and then store all your tokens there and then send any requests from clients to a backend, and the backend's going to hold the tokens because it's a much bigger lift to steal a token from a server-side data store than it is to steal a token from a client-side data store. So this often happens in SDKs. Philip Derek has a great presentation about how using OAuth tokens in JavaScript single-page applications is really a risky thing to do. So we have that authorization code grant that we walked through before, and I'm not going to go through the whole presenting the username and password or getting the authorization code. I'm going to start with the token exchange. Everything else was as before. So instead of passing the tokens back to the client, we're going to store the tokens in our application, in a session, or in a Redis data store, or in some way. And then our client makes a request not of the Clown API, but of us. And we have a lightweight proxy. We recognize that. We can make that request against the API, but we can pass tokens along. So you get all the strengths of the tokens in terms of they time out, in terms of the Clown API being able to validate them without ever talking to the identity server, but you don't ever send the tokens down to the client. You get back the Clown's JSON, which is then passed back to the client. Some benefits of this pattern are you have enhanced security, you have enhanced knowledge of how the tokens are used, you can call out different APIs and not worry about stuff like cores or other limitations that particular clients might have. Trade-offs are you're back to sessions, essentially, for your interaction between your client and your application. It's going to be custom code, not a lot of custom code, but some custom code. All your traffic goes through this BFF proxy for all your APIs. That means that now is something that you need to think about scaling up and making it sure it's available. It's another architectural component, right? So again, you're getting a trade-off of you're getting more security, You're getting a lot more insight, but you have another thing that you need to build or maintain. Let's talk about the username first pattern. This basically allows for more intelligent routing. Instead of asking the user for their credentials first, we actually asked for some kind of identifier, and then we can, based on that identifier, send them to their preferred method of authentication. Zapier does this, Microsoft does this. I've definitely seen other people do it, but here's an example. You will enter your email first, and then from there, you'll be routed to different authentication options. It also works because you can use this as a way to migrate users, because it doesn't have to be something that's obvious to the user where you're sending them. You could send them to a screen that looks just this. You could send two different users to two screens that look the same, but are backed by different user data stores as well. So here's how it might work. You basically have cosmosilencer.com, which is an identity server, and you have this user come in and they enter their email address, and we send them to Facebook to authenticate. This other user, we send them to an OIDC Connect server to authenticate. And the third user, we send them to the local password form. So all three users, based on their identities, are sent to different places to actually prove their identity. So the user can be more intelligently routed. As I mentioned, you can layer in different authentication methods. Those could be different owners of identity that are third party, right? Like Google and Facebook that we saw previously, or it could be different local identity stores. If you're migrating users between different identity stores because you have just a ton of users and you're switching between different identity providers or things like that. So actually, in some ways, this complements this flow migration pattern. There's a trade-off, of course, is that people can just put in whatever they want in those username field. Attackers may explore that username field, right, and see what the space of users are that have an authentication method. And it can be a little bit confusing for users sometimes because it's kind of a newer pattern, and some password managers may have a hard time with the username on one page and then the password on another. The next pattern we're going to talk about is impersonation. This is basically the assumption of another identity to allow you to have elevated or different access. It's useful for customer service troubleshooting. You probably want to limit it to certain applications. So you want to think about this because basically, if I can act as another user, I need to be a trusted user myself. Otherwise, you certainly wouldn't want to let other people act like other users, just typical normal users. People that might have elevated access would be like admin users, as mentioned here, like customer service users. Another case that we see often is parents having elevated access to act on behalf of their minors inside an application. So some common limitations. This is not necessarily a web application, right? But SU or sudo in Unix does this. RFC 8693 specifies how to implement impersonation using tokens. And then there are some gems out there or other libraries like the Pretender gem that can help you with doing impersonation inside your application. The way this works in a token-based situation is that you get a token as a client, and then you present that token, which is part of your identity, which shows your identity to this pseudo application, which then will pass that token to the identity server and get back a different token, right? And this is the elevated access token, and you store that off, and then you can present that to the e-commerce store. And so you can do this to act as if you are user 2 when you're really user 1. The benefits of this are that it's better troubleshooting. It's very useful for development because you can kind of like pretend to be other people to like see whether you can recreate a bug. Some of the trade-offs are things you need to think about. You want to make sure you audit access to this pseudo application very carefully. It's an escalation problem, or it's an escalation solution, and escalation always has the worries of someone escalating outside of where they should be to gain access to things that they shouldn't gain access to. So in conclusion, we talked about a bunch of different identity architectural patterns, and I really appreciate your time. If you want to learn more, here is a couple of additional resources. We have an identity basics section of our website, which talks a lot about different aspects of identity. There's an identity professional's body of knowledge that is very helpful in terms of getting your hands around some of these concepts. And then this book is really great about talking about identity management in modern applications. It's really focused on token-based identity management.